Welcome everyone. My name is Bogdan and I work as a consultant for Mindfuel, a STEM education organization committed to supporting teachers and students. Today I am going to present to you our digital coding resource, Codingville. Codingville was designed as part of the government initiative CanCode between Mindfuel and our partner RoboGarden to bring the concepts of coding to youth through a game-based coding platform that uses both block coding and HTML, CSS, and JavaScript. This webinar will take you through the Codingville platform and provide you with an in-depth look at the resources, functions, and features to support you as a teacher in Codingville, along with 2 demonstrations of Codingville game-based journeys. You can follow along by signing up for a free account at codingville.ca. Let's log in. As you can see on your left-hand side of the screen, there are several menu options. We will be going through each one and discussing how to use it and its main features. First, let's click on the dashboard. The dashboard is a quick overview for you, the teacher, to view the number of students activity. For example, you can see completed missions versus time, top 10 students. This classroom percentage is out of the total number of journeys assigned to the classroom, the number of journeys, recent activities. For example, my star student Bill Smart finished the first journey, the number of classrooms, and classroom scores. So, for example, we have one student with a score between 3,758 and 4,533, one student between 1,431 and 2,206, and one student between 660 and 1,430. And we also have an activity log. Instead of these graphs, in the beginning, your dashboard should display a message such as this one. No progress to report, waiting for student actions. This indicates you don't have any student data. In the Classrooms tab, you can create the group of students or classroom that you are planning to work with. So let's click on the Classrooms tab. Here we can create a new classroom. So let's click on plus create classroom. And then let's give it the name Young Programmers. And let's say grade somewhat arbitrarily 8, so grade 8. And create. Here we have a new classroom. Now, let us notice that this classroom in the middle, Young Lions, has a rather aggressive name. So let's change it. We're going to click on these 3 dots and then edit. And we're going to change the name from Young Lions to Young Minds. Good. Now all the names are proper. Once inside your classroom, you can assign students to the classroom and the journeys you would like your students to work on. I'll talk more about journeys, but for now it means course content. So let's go inside Young Programmers. I will now show you how to assign both students and a journey or journeys to your classroom. So first, let's assign students to the class. We are going to go to the Students tab, and here we are going to click Add Students. You can add students in 3 different ways. Method 1 is you can copy this code and email it to your students. Then, when they sign in the first time, they will provide this code, which will allow them to register in your class. Now, method 2, by uploading a comma-separated values file or a CSV file. So let's click on the upload button. And here, we're going to choose a file. We have one prepared. Now here you can also download a sample file so that you have a file format example. But for now, let's just click add. Here we have 3 students right away in our classroom. Finally, we have method 3. We're going to click add students again, and we're going to add a single student. So we're going to click the button add. We're going to give a full name of, let's say, Jack Lehen, and the username of Jack Lehen. I will type in a password, and I will retype the password, and then click add. To assign which journey you want your students to complete, you can assign it in 2 different ways. First, within the Classroom tab, you can click Journeys, and then on the right side, Add Journey. And here, assign these 2 journeys. The second way is that you can add journeys under the Journeys tab in the menu. So here we can add this journey by clicking Assign and then checking Young Programmers. We can also assign Skills Practice under this tab to assess where each student is at. You might have kids at different levels and try to achieve the same readiness level before the journeys. This is a great way to balance different learning styles and skill levels. Let me summarize what I did with this class, this new class. I added 4 students and 3 journeys. Now I have to change focus to a classroom where I have more student data. So let's go to Young Coders. All progress tracking is found in the Classroom tab. So let's click Progress on the first journey. You can see the details of the number of times it took a student to complete a mission and their overall progress through the adventures of the assigned journey. So, for example, if I look at this adventure, let's climb, I will see that Bill Smart took 3 tries to complete this mission. So now let's see one more tab. Under Young Coders, let's click on the Projects tab. Here we see the projects that the students have built in our class. Let's now go back to the Journeys tab. Currently, there are 4 journeys within Codingville. Coding using blocks, beginner level for grades K to 3, game-based and deals with blocks. From blocks to JavaScript, intermediate level for grades 3 to 6, game-based and uses blocks but has a converting option to see how the code blocks translate into JavaScript code. Coding using JavaScript, intermediate advanced level for grades 6 to 9, game-based using both blocks and texts, and you have to fill in the missing text code as it matches the code blocks. And Junior App Development, an advanced level journey for grades 7 to 12. It's about learning HTML, CSS, and JavaScript, and how progressively one works through building an app or a game project while learning the coding concepts. As a teacher, if you would like more information on each of the journeys and to try them prior to assigning to a classroom, you can simply hit info and then try. Each journey is made up of a number of adventures. Each adventure has several missions within it. The missions are tied to different outcomes, such as sequences, loops, functions, and Boolean logic. Each journey is approximately 15 hours of assigned time and around 6 hours of project work. The first two journeys are focused with an end project of building a simple game, while the last journey is focused on a final project of building an app. Let's now see what is in these journeys. Let's have a demonstration. We will load from blocks to JavaScript, adventure 6, mission 6.
All right. It's time. We need to get those coins with minimum number of blocks.
Okay. We have to collect the gold coins by walking through the E-shaped maze. One of the most natural examples of repetition or loop in nature is walking. Step right, step left, and repeat. In our case, Robo will do the walking by just stepping forward. The challenge for us is to have the right orientation for Robo and to repeat the correct number of steps forward or backward. There are two ways to traverse the maze, and you will see both ways demonstrated here. As a teacher, encourage your students to traverse the maze in their mind or on paper. This is the first part of the challenge, constructing the algorithm. Then the students will convert to code blocks. Converting to code blocks is a secondary challenge, more about syntax and language. How to communicate the algorithm to the computer or to Robo, if you prefer. So let's do it. Let's traverse this maze. What we should do is to insert the blocks from the left side of the screen. So we could probably start by rotating right and then starting a repeat block with several forward steps. Okay, but this would be rather time consuming, and instead we're going to use my saved solution. This is the first way to traverse the maze. So let's go to this gear and let's select load progress and the maze special. Now we have the solution and we're going to hit debug. I just want to mention that teachers should encourage students to use debug to test their code. This way, it will not count against their attempts or points if they make a mistake. Students have to understand that as a programmer, you are not penalized for testing. On the contrary, you are encouraged to test your code. So yeah, on a normal day, this would work flawlessly, but today I made some mistakes for the sake of educational theory purposes. So this code needs a small correction. We have to change rotate right to rotate left. And let's hit debug again. So Robo is going on the bottom path. He's gonna get the gold. He's gonna turn right. And 1 step, 2 steps, 3 steps. See, the block that is being executed is highlighted on the left. So for example, right now you see how repeat 4 times step forward is being highlighted as Robo is executing it. And now Robo is gonna go back. Debug is a little slower, but you heard what are its advantages. So now Robo is gonna go up and then collect the gold, and then hopefully complete the mission. So a few more steps to the right. 1, 2, 3, 4. Excellent. So mission accomplished. To see the other solution for traversing the maze, we can go to the gear and use the show model answer feature. This is of course available only to teachers, and it provides the system solution. Here we are going to click run since we are quite confident the solution is correct. You see how Robo this time is going to go all the way up to the top path rather than to the middle path first. So the difference between the two ways of traversing the maze is whether you complete the middle path first or the top path first. In this lower right corner, we have a button, Show Equivalent Code. This button is available only in this journey from blocks to JavaScript. This feature translates the code into JavaScript. And it is important if you are in the process of learning JavaScript. The next example mission is from coding using JavaScript journey. So let's go there. A few words. Algorithmic thinking is not new, and it is familiar to most teachers. Converting to computer language is a specialized skill that requires experience similar to learning a language. Using blocks is easier than writing text. Freedom really complicates the process because you have a lot more options with one or a few right answers. If writing algorithms is easy for your class, but they need more practice with writing code, especially JavaScript code, the coding using JavaScript journey is for your class. In the coding using JavaScript journey, we are going to focus on example Adventure 6, Mission 2.
Using the least amount of coding blocks, repeat the movement 9 times forward to start the climb and pick up the shovel. To get to the shovel, you should use the repeat times coding block. This block is a loop command that repeats the actions as many times as you determine in the loop.
So now that we heard the instructions, let's go to next and see on the left side the code blocks. These are the code blocks that have to be converted to JavaScript text code. And if we click next, we are going to actually see the translation of these code blocks into JavaScript. So now we see that in the mission instructions, the translation from code blocks to JavaScript is given. In a sense, we just have to repeat it inside the mission. So let's click close and take a closer look at the mission. The algorithm is written for you in block format, and we have a repeat step loop, just like the one described in the previous journey. So the only additional effort required is to convert to JavaScript text code. Your class needs to understand the element of a for loop in JavaScript. It is your choice if you let your class discover the for loop or you describe it to them. The main computer science outcome is to understand the idea of a loop. Writing a loop in JavaScript is the secondary outcome. So let's do it. Let's convert these code blocks into JavaScript. We are going to start with the keyword for, and then using the standard syntax, we are going to declare a variable and initialize it to 0. And then we are going to define a range or a condition for this variable. And we are also going to specify an incrementation method. So we're going to increment by 1. And now all we have to do is to specify the instructions to be executed by the loop. So in this case, we're going to open some curly braces, and we're going to click on, or we're going to type R, and we're going to see this drop-down menu and select robot step forward, which is the match for the instruction step forward on the left. So step forward, and let's put the semicolon. So what we did here is the following. For each value of the variable count from 0 to 8 in steps of 1, we are going to execute robo step forward. So now let's hit compile and see what happens. Okay, so mission accomplished. I want to bring to your attention a different topic, that of projects. Let's go to the journey coding using blocks. Within most journeys, you will notice a puzzle piece at the end of all these adventures. So adventure 1, adventure 2, adventure 7, adventure 8, and then puzzle piece. This indicates a project section. At the end of each journey, students build a game along with a tutorial to familiarize themselves with game development, or they can build their own projects. Students can share their apps and games and have friends and family and classmates play them. Let's have a demonstration of this project, Get the Ring. Your robot, Robo, is on a board 4x7 with some traps that it has to avoid, and it has to find the ring. This is the code. We have to catch these events. So to allow Robo to move, we need to process the joystick events. For example, when joystick is right pressed, we have to select the action slide right. When Robo collides with a trap, we have to select game over. When Robo collects the ring, we have to select game complete. You need to follow these instructions on the right to build the code properly. We will use the model answer to speed up the process. And now let's play the game project. Next, for instructions, next, finish. And now let's run the code. And let's click play. Robo is gonna move to the right, and then up, and then to the left, and then he will find the ring. And we have a victory. We also have a project tab in the dashboard. So let's go there. Let's click on the project tab. This section allows you, the teacher, to practice project concepts yourself, so you can build one out that your students could use. And this is an exploration opportunity for your students to practice the concepts they have learned throughout the journey. If you have some students that are going through at a faster pace, this is where you can encourage them to self-explore and build out different games and apps that can be shared. So for example, if I click on these three dots and then I select menu share, I am given a link which I can provide to my family and friends to experience the game that I built. Let's now click on the Discover tab. In the Discover tab, you can view student projects, further track their progress in more detail, and view badges that students have earned as they are going through their journeys. Let me clarify which are the badges and how to see the projects. So the badges are these bitmaps here underneath the Fox, and the projects are on the Projects tab, and here you can see Bill Smart's game. Now, students can receive badges for anything from completing the missions with no mistakes, to encouraging other projects and work, to creating their own games and projects. Students will see badges in their own accounts. You can use this feature to motivate your learners as they are working through the missions. Let's now discuss the Training tab. In this section, you can find resources that might quick help you or the students with the missions. So let's click on Programming Concepts and then Loops. Here, you will find a document. In this document, you find information about how to convert from the repeat code block to JavaScript for loop. If you scroll down, exactly what was needed in the previous example missions. You can also find some lesson plans if you are thinking of a more traditional approach of teaching computer science in pen and paper, for example. Better said, outside the platform. So let's go to these lesson plans. I am going to present the lesson plans related to the topic of the day, loops. The first lesson plan, L10, Identifying Loops, is a lesson about how to identify loops in dance moves. The second plan, L13, Loops in Nature, is a lesson which includes Mark Zuckerberg teaching loops, or how to say happy birthday to everybody on Facebook using a loop. The third lesson plan, L3, Iterations, Repetition, Loops with Python programming, is developed by myself. It's in Python and probably needs to be converted into JavaScript. It is quite a comprehensive description of loops for high school computer science level. Besides loops, the lesson plans describe other computational thinking concepts such as sequences, conditionals, functions, events, and parallelism. There are also other unplugged activities for all grades to help you connect real-world concepts to coding. We will be happy to share out our training manual or provide more information or ideas if needed. So for now, see you soon in Codingville.